All right, so this week's challenge was to write a game. I did not write a complete game, uh, but I wrote pieces that could be turned into a game. And the reason it took me a week is because it's the first time I actually completed some code using assembly code, machine language code. Um, Up until now, I've been using high level languages, but this is the first time I wrote something in machine code that works. Of course, when I showed my wife what it was, she was totally bored and said, "What is that? All it does? What does it do?" So anyway, I'm going to show it in a minute, but this is what some of the machine code looks like. So a bunch of equates and some data, and then some opcodes for the computer to do some things. Then after you've written your assembly code, you assemble it. Now what I'm about to show on this computer from, almost 40 years ago still works today because the way TVs work today in 2021 is still a lot like how TVs work back in 1981. And that is what you see on your TV screen is actually a set of still images that are redrawn every 60 times a second or 30 times a second, depending on what computer you have and whether you're in North America or Europe, where it's 50 and 25. So what happens is how this screen is actually being drawn is a line starts up in this top corner, draws across to here, turns off, goes back to the start, draws again, and then it'll do that, fill that whole thing so fast that it looks like one image. And as things are moving on the screen, it's changing 30 times a second on this screen here. So modern TVs in 2021, so a 1080p TV is because it's actually drawing 1080 of these lines across the screen. Progressive scan means it draws from line 0 to line 1080, one after another. Some of the early ones would write every other line and then go back and write the lines that they missed. So that's why it's only 30 times a second instead of 60. So when this line that's being drawn gets to this side of the screen, the what's being written gets turned off and moved back to the left side and then drawn again. The timing of this, when this turns off to gets back over to there, is called the vertical blank interval. And the computer can do a bunch of things in that timing. So here, in that brief second, not even a second, obviously, because it's 30 times a second, and then the Atari can display up to 320 lines of vertical resolution. And so it gets turned off 320 times. And then in between there, if you can write machine language code, that will happen in that instance. So what's happening here is it is scrolling the letters across the screen. And then I also created what in Atari is called a player missile, but other people may know them as sprites. So here's my showing that I can move the RSI logo. This is a sprite that is independent of anything else on the screen. So this is how a lot of the early video games are written, is you would have sprites that you could move around independent of the screen, and then people would redefine characters, and what is now letters scrolling across the screen could be ships coming at you, and this will wrap around both ends. So that's what I did. And I actually defined that RSI logo the old-fashioned way by mapping out the bits. So the RSI logo is basically 5 pixels high and 8 pixels across. Those 8 pixels represent bits of an 8-bit byte. And then using assembly language, I can translate this into a series of assembly codes. Oh, forgot I moved that line. I'll find where it is. So how this works is when the vertical blank interval is happening, the Atari has a separate video processor chip called Antic, which controls the video while the computer does other stuff. So while Antic's drawing the screen, I can... and I missed it. So while Antic's drawing the screen, I can do programming computations like scrolling the letters or reading the joystick. And there it is. There's my shape here. So I have some blanks on the top and the bottom. And these are the bytes that I mapped out here to make the RSI. You can see I made a first attempt, which I didn't like because I didn't like how the S worked, so I redid it to this final version. And so here is some of the code that reads the joystick. So every direction that I push this joystick in, up, right, left, down, top corner, other top corner, and the 2 down corners, puts a value into a memory location of what direction I push the button. And so what this does here is saying, did I push it to the right? If I did, that value in there would be 7. If it's not 7, then look if I pushed it left or if I pushed it down. And in this case, if I moved it right, I'm going to take the current horizontal pointer to where the location of the RSI logo is, increment it by 1 on the X value, and then store it back in the pointer for next time. And then this is the horizontal position of player 0. So and that is my demo. Maybe I'll turn this into something else, but there you have the magic RSI logo in my first assembly language code. Thanks. Bye.